Hi, I'm Janine Cody, Director of the Chromosome 18 Clinical Research Center, and I'd like to explain what our gene dosage and phenotype dosage maps are and a little bit about how to use them. So why would you want to use these maps? First of all, here's the URL where they're located on our website. And if you are interested in the role a specific gene might play in a deletion or duplication, you might want to look at the information on our gene dosage map. Likewise, you can look up a phenotype associated with a condition related to chromosome 18 and see the region that it is linked to. Even though the specific gene has not been identified, many of these regions are relatively small, so you can see what phenotypes are associated with the region or what region a phenotype is associated with. But you can also look up the clinical consequences of a region. So if you're interested in someone who has a deletion or duplication of a certain region on chromosome 18, you can look up that region in our gene dosage map and see what is known about all the genes in the region relevant to gene dosage, meaning abnormal number of gene copies. And you can also see about the phenotypes associated with that region as well. So it can at least give you some starting information to have a clinical picture of that region of chromosome 18. So our gene dosage maps, our phenotype maps, are designed as custom tracks on the University of California, Santa Cruz Genome Browser. And so here's their URL. And this genome browser has the data on genomes, as you can see in the little pictures here, from humans, mice, rats, fruit flies, worms, yeast, all kinds of different organisms. Of course, we're interested in humans. So what you need to do when you go to this website is go to this region right here under the human assembly. And what you want to look for is the assembly that says February 2009 GRCH37/HG19. HG19, Human Genome Build 19. So that's what we want. Select that from the drop-down and then click Go. And that will take you to a page that looks something like this. And most of the data in this at this website is not really clinically applicable. And so there's all kinds of information that you probably are just not going to care about. So the first thing you need to do is find the bar here with all these buttons and click on the one that says Hide All. And then it won't be so overwhelming, and we can control what you're looking at, and what you see only what is going to be relevant and meaningful to you. But the view you're going to see is going to be arranged something like this. There's a box right here, and this indicates the region that's being viewed in this particular view on the browser. And that exact region is shown on the chromosome ideogram by a red box. So you'll always see a red box around some region of the chromosome. So this is the region we're looking at here. Below that is a viewing window. Now we've clicked Hide All, so there's not much in this viewing window. It's very skinny. So this is the viewing window of the details of what's within this red box. So it's a zoomed in view and has all those details. Below the viewing window, you'll probably see a whole row of these dark blue bars. There's maybe 20 of them. There's quite a few. And if you click on the plus under there, then it'll pop open and you can see all these choices here. These are all different tracks of data that you can look at that are freely accessible, but most are not applicable to someone who has a clinical interest, which is why I said start with Hide All. You don't need those. There are probably, 100 or 150 of these different tracks of data in different ways the human genome has been annotated. It's fascinating stuff, but mostly not clinically applicable. So that's why we started with Hide All. And so the next step is then to select the parts we do want to look at. So these are the things you want to do. You want to go to where it says Base Position, and you click Dense from this drop down. Then you want to go to the chromosome band and also pick dense from the view of chromosome bands. And then look at down here under the blue bar that says genes and gene predictions. You click on the plus to make sure it's open so you can see all the different kinds of data for gene predictions. But we want to look at the UCSC genes. And so under that, you want to, that drop down, pick pack, and then click on any refresh button over here on the right. And then your screen should look just like this if you select this region of chromosome 18 that I'm showing right here. And you select that, type that into this box right here, and then you should see exactly what my screen looks like. And let me explain a little bit more about what you're seeing here. So now here is the base position right here, so you can see exactly the base pair numbering right here. Below that is the chromosome band, so here are the black and white and gray bands you're used to seeing. And below that are all the genes in this region. And the genes are designated by little bars here. Some are skinny, some are skinny like that, some are fat, some are made up of whole groups of bars connected together. But those are the positions of the genes, and their acronym for their name is next to them. And what you can do from here is you can click on any one of these genes. In this case, we've selected the t-shirt gene, TSHZ1. So if you click on that gene, then it will take you to their detailed page about that gene. There's all kinds of different information here, but more importantly, there are links to other databases here with information on that gene, much of which is summarized right here on this page. But the ones with clinical relevance are OMIM, Online Mendelian Inheritance in Man, and PubMed, so the references, the medical literature. And so if you click on either of these, that will take you to those websites and the information on this specific gene in that website. So that may be something that is of interest to you. So that's how you use the genome browser in general and how you navigate through it. You can zoom in and zoom out. You'll see the buttons there. And to use our gene dosage maps, they are custom tracks on the genome browser. And so if you go to our website, shown right here, you will see the instructions for how to use our gene dosage maps, how we determine the classifications for the genes and the regions. And you will see that we have 6 different maps. So this is version 2.0, very different from our last version, which is why I thought I had to redo the video. We now have 6 different maps instead of 2. And so this year, when I did my annual review of every single gene on chromosome 18 and every single phenotype associated with chromosome 18, it started to become clear that we were getting enough information about duplications that the duplications could have their own map and should be separated from the deletions. So that's what we've done here. Hemizygosity gene dosage is hemizygosity is about the deletions, so 1 copy instead of 2. Suprazygosity is about duplications, so that could be trisomy or tetrasomy in either case, but supra meaning more, so too many copies of the gene or the region of 18. And again, the gene dosage maps are the annotations of every single gene on chromosome 18. The phenotype dosage maps are the phenotypes or the diseases or conditions related who've been linked to chromosome 18 in some way by a variety of methodologies, but the exact gene that causes that has not yet been identified. So we want to know about the things associated with the region of chromosome 18, even though we don't know the exact gene yet. And then the last 2 maps are on clinical dosage maps. And those are here because most of the genes don't have an effect when you have a deletion or a duplication. And many of the regions are probably not going to be relevant to having a deletion or a duplication. So we have a set of maps that just deletes all the stuff that's not relevant to a clinical picture. And so the just focused on the clinical, we have 1 map for Hemizygosity has the genes and the phenotypes, and one for superzygosity, which are the duplications, and again, that's the genes and the phenotypes together in those maps. So those are the maps. Now within the maps, each gene in the gene dosage map is color-coded by what we anticipate at this point in time to be its effect. So in the hemizygosity map, every single gene on chromosome 18 has been, if there's enough information known, to make a guess at this point about what its effect will be. Those color-coded blue, we think, have no clinical effect. So either there's no effect at all, or it's maybe a difference in the level of something in your blood, but never enough to cause disease. So those are color-coded blue, and the data we use to make all these classifications are shown on our website, so you can read what data we use to come to these determinations. Those color-coded green are risk factors. So that might be a gene that's deleted more often in someone with autism than in someone without autism, which it may play some sort of small role, but probably takes 5 or 6 other things. So pretty much wouldn't worry about it, but you really want to know that it might have some effect. So those are the things. Risk factor might be something like 1 in 1,000 or 1 in a million chance of having this disease because you have a deletion of this risk factor gene. So very low probability. Then the next category are those things that are conditional. So those genes do not cause a problem when you have a deletion or duplication in and of itself of that gene. You need something else. You need a mutation or deletion or duplication or something of another gene, or a specific environmental exposure, a certain drug or something that also you have to take in order to have a disease related to a duplication or deletion. So these might be recessive conditions that are on chromosome 18, where you have a deletion of a gene, but you don't have the disease unless you also have a mutation in your normal existing copy of that gene. So these are the things that are low probability, maybe 1 to 4% is our best guess. So those are color-coded purple. So again, those aren't high risk sort of things. Then there are those things color-coded orange. Those are low penetrance. You have a deletion of this gene. Then you have maybe between a 4 and 50% chance of having the problem that that gene causes. So not everybody, but a lower probability. And then there are those that are causal. And those genes are the ones that have more than a 50% chance of having whatever effect. And so those are the main things you want to focus on, look for, investigate, and be aware of. Then there are those genes that are haplolethal, and we don't know of any of those yet, but there are a couple regions on chromosome 18 that even in our 650 people with deletions or duplications, in this case deletions of chromosome 18, that nobody has a deletion of this region. So there probably are genes that are haplolethal that no one's going to have a deletion of, but we just don't know what they are yet. So the color code exists, but there aren't any in that category. And then there's a few genes that are unknown. They might even be hypothetical genes. Nothing is known about them. I can't even venture a guess at this point. And I want to emphasize that all of these classifications are based on the best data we have to date, which can change. But so stay tuned. We update this all the time, but we still need to know what it is that's known so far. So that's what we're conveying to everybody here. Then the duplication or the superzygosity gene, the genes are also scored or classified related to duplications or superzygosity. And again, the classifications are pretty much the same. There is no haplolethal gene because we assume there aren't any haplolethal since people exist with trisomy 18. So I'm sorry, duplolethal is what they would be. So there's not even a category for that. We think it's not applicable at this time. So to review where we are at this point, of the 263 genes on chromosome 18, we think that 155 have no effect when you have a deletion of those genes, and 147 have no effect when you have a duplication of those genes. So that's the vast majority of genes really don't have an effect. So this isn't as big a problem as people once assumed it was. 17 we think are risk factors and, when you have a deletion, and 5 risk factors if you have a duplication. So again, these are the things, risk factors for conditions that you might see 1 in 1,000 or something. Conditional are those things that require one other something to exist, one other gene deletion or duplication to exist. And there are 45 genes that we think this is the case if you have a deletion, and only 1 if you have a duplication. The genes associated with low penetrance, so less than 50% chance of causing a problem, there are 8 of those genes on chromosome 18, and none have this classification yet as far as duplications of those genes. There are 15 genes on chromosome 18 that we think cause a problem when you have a deletion in more than 50% of the time, and only 1 if you have a duplication. Haplolethal, as I said, there aren't any genes yet, but there probably will be, and it's not applicable for the duplications. In the unknown category, genes which I can't even venture a guess about their role. There are 23 of those when they're deleted and 109 when they are duplicated. So we know a lot less about the duplications, but we're working on it. We're getting there. It's just, it's a harder nut to crack because it's just much more complicated for a lot of different reasons, but that doesn't mean we're not working on it. So the phenotype tracks. So again, these are regions of the chromosome associated with a certain disease or clinical feature, and there's a specific region of the chromosome known. That region might have 50 genes or 3 genes, but it's a region, and the specific gene is not known yet. So the classes are very similar to the gene classifications. Blue is not related. Orange is low penetrance, so something like between 4 and under 50% chance of having causing a problem when you have a deletion of the region. Pink is causal, brown is haplolethal, and 5 is unknown. And similarly with the duplications, they're also color-coded in by the same sort of scheme. And the number of phenotypes associated with deletions, hemizygous or superzygous duplications of chromosome 18 are shown here. There are 3 of each category that we think aren't really relevant at all to having a deletion or the duplication. But we won't know for sure until the specific gene and more genetics is understood about those conditions. 37 are low penetrance for deletion and 7 for duplication. 12 are causal, and these are mostly our critical regions that we've identified as being associated with an 18q or P deletion. So they cause a problem more than, or it's a problem that we see in more than 50% of people with a deletion of this region, or problems that we see in more than 50% of people with duplications of the region. And there's only 2 of those regions for the duplications. As I said before, there are 2 haplolethal regions, and there are multiple regions associated with phenotypes or diseases that we have no idea what the genetic mechanism is, and so those are unknown. And there's 25, and since it's not known whether it plays a role in deletion or duplication, so there's 25 of each of those. So this is where we are as of January of this year. And here's a picture, a screenshot, a partial screenshot, because I've cut off all the other tracks that are shown below on the website. This is a viewing window for this region of chromosome 18, which is shown in the red box here. So it's the end of 18q. And this is the hemizygosity map of gene dosage map for this region of chromosome 18. And two things are showing here. Here's our gene dosage map here. And below that, these are the UCSC genes. And so you can see every single gene in the region. And you will see that every single one of these genes has a corresponding classification for that gene shown up above in our gene dosage map. And you can see, first of all, that most of them are blue because we think they have no clinical effect when you have a deletion. But here's one that's pink. It's TSHZ1, the T-shirt gene. So you can click on that gene, and it will take you to this page in the genome browser, their details page, which then you have to click on this, the name of the gene again, and then it will take you to our page, which shows you our data about how and why we made this classification and all the scientific references that allowed us to make that classification. So there you can find out more information. This is our phenotype map, and in this case, you'll notice right away, here's the red box around the entire chromosome 18. So that tells you that these coordinates are for all of chromosome 18, and that this viewing window here shows all of chromosome 18. So these are all the phenotypes associated with chromosome 18 for which the specific gene is not known, but a specific region is known. So you can, again, click on any one of these. Here's DM2, delayed myelination 2. So you can see it's a pretty small region down here. And if you click on that, then it takes you again to the Genome Browser's detail page where you have to click on the name of that again, the region again. And that takes you to our details page with more information about that specific phenotype and what we know about it so far, and the references that help us determine that region. And if you look at our clinical dosage map, that, as I said, is only the genes and the phenotypes related to, in this case, a deletion, because this is the hemizygosity clinical dosage map. And you can see, you don't see that same top of the page or bottom of the page because it's a very long page and I couldn't get a screenshot of all of it. So this is just the central viewing window. But it is the whole chromosome view of the clinical classifications, clinical hemizygous classifications for the genes here, and all the phenotypes here, the hemizygous phenotypes shown below. And what you can do then is enter a specific region of chromosome 18. As I said, this particular window shows the whole chromosome. You can zoom in, let's say, to this region, just to pick a random region. And when you select that region up above and hit refresh, it would take you to a screen that only shows this region right here. And then you can click on every single gene and learn what we know about every single gene. And you can learn about every single phenotype here. Now I'm going to record another video that shows two examples, and so you can contrast how what you learn from one example is so different from what you might learn from another example. So it really illustrates the usefulness of these gene dosage maps. Again, all the instructions are on our website, so hopefully you'll have that as you work through this the first time. And if you have questions, comments, helpful hints, whatever, we want to hear from you at the Chromosome 18 Clinical Research Center, and the responsible person to contact is Annis Hill, our program manager, and here's her email address. If you email her, she will get your question or comment to me, and more importantly, she will bug me until I answer you, because I get a lot of email and things can get far down on the list and I forget. And so she's my memory, and she's the one who holds me accountable for answering. And if really the question is for someone else on the team, she'll do likewise for them. She'll forward them the email and make sure they answer you. So thank you for being interested and caring about people with chromosome 18 abnormalities. Our goal is to make the chromosome 18 abnormalities the first treatable chromosome abnormalities. So help us do that, and thank you for your attention.